So today we're going to look at how to find the surface area and the volume of a sphere. So first of all, when we talk about a sphere, there's a couple of things again that we need to talk about. There is a center of a sphere, and there is a diameter and a radius. Now again, the radius is what we'll be using mainly, so this distance right here is going to be your radius. But again, if they give you the diameter, just divide it in half and that will give you then your radius. Now, if we were to cut the sphere in half, like this image is trying to show for you, it's referred to as a hemisphere. So when you cut a sphere in half, there's two halves to it. Now, this is kind of important when we talk about surface area because now you actually have a circle to add into your surface area, and you have half of the surface area of the outside of the sphere. So formulas, these will be given to you on the provincial sheets, but you have your volume formula and your surface area formula. Your surface area is 4 times pi times your radius squared, and your volume is 4/3 times pi times your radius cubed. So our first example, we're going to find the volume and surface area of a sphere with a radius of 10 centimeters. So let's do our surface area first. So surface area is going to be 4 times your pi times your radius squared. We have a radius of 10 centimeters. So for your surface area, you'd have 4 times pi times 10 squared. And if you needed a diagram of what that looked like, the best I can do here, we'd have a radius here of 10 centimeters. So surface area then becomes 100 times 4, so 400 pi, and we're talking in centimeters, and it's surface area, so it's centimeters squared. Now for volume, that is 4/3 of pi r cubed. So same thing, we need a radius. Our volume is going to be 4/3 times pi times 10 cubed. So that's going to be 1,000 times 4, so 4,000 over 3 pi. And again, our units are centimeters, so we're looking at centimeters cubed. So that's how you'd find your surface area and your volume of that particular sphere. Now, a little bit trickier of an example is when you have a hemisphere and we're looking for the surface area of it. So in this case here, for touchable surface area, you would have the portion on the outside of the sphere, as well underneath it sits on a circle. So we would have to have, for surface area here, you would have your 4 pi r squared, but we have half of it because we don't have the outside portion of the other half of the hemisphere or other sphere. Plus you'd have the base here with your radius of 5, so pi r squared, but we would substitute in for our radius our 5 centimeters in this particular example. So we can work through this. The 4 and the 2 will cancel out to give us a 2 pi times by 25. So we would have here so far 50 pi plus 25 pi. They are like terms because they're both in terms of pi, so we'd have 75 pi, and then it's centimeters squared for our surface area. Key thing to remember is that we'd have half of a sphere for the surface area on the outside, and we'd have a base that is your circle. Now if you were looking at a quarter of a circle, you'd have a little bit more work to do, but similar idea. You just have to logically think about what you can touch on the quarter of a sphere. Now for volume, if this was a question about volume, it would just be half of the volume.